We were at 34 days yesterday. Now we're 29.
I took off the exam days. Because I only have 30 days left counting the exam days. Some people might have 34.
Whatever.
Might have 30.
All right. So cesium has how many outer shell electrons? One. All right. Oxygen has how many outer shell electrons?
6.
All right. So cesium is going to do what with its one electron? All right, so cesium is going to have a +1. Oxygen is going to gain it, which means it will only have how many? So CS has to be added. It will donate 1 to oxygen. It lost 1. Oxygen gained 2. You need to balance by putting a 2 here. Everybody go with that? All right, aluminum has 3. Fluorine has 7. So aluminum will do what? Give all 3 away. So fluorine gained how many? 1. All right. Now I have 2 that are still floating around in space, right? So I'm going to add what? 2 more fluorines. All right. Each fluorine has 7. So each of those fluorines gains 1. What oxidation number do they have? Okay. See, that's what happens when I erase. Lose my pen.
So you guys do it 3 by the AM? Right?
Yes. So there's -1, -1. Then I can put a 3. Whoops.
Just don't erase.
Oh, there we go. I wrote it in the right place.
Scratch it out and keep going.
There you go. I can just do a lot of scratched out today. That's a good idea. All right, questions.
Y'all better keep up.
I'll just scratch out. It just won't look pretty today. I just got to remember I can't erase.
It's okay.
You know, I've been erasing a long time. I'm going to forget. All right, questions about the open. All right, let's talk homework.
Ooh, about that. Are we
All right.
checking it?
Yep, I am.
I have what, 2 60s? 0s on break?
That's what I'm saying. I know it is here.
All right, pull out. Let me see today's.
Wall's going crazy. You've been checking it so much lately. It's what I've been on it.
I did part of the homework. I can get what, 15?
Okay.
I've actually been consistently doing my homework.
Good.
Do I understand that? Absolutely.
Are they clean?
I thought you were watching the hands up.
I don't want to watch it.
All right, so you're missing that. You're missing that.
No, Madison, I was going to do this with Carol.
Yeah.
I don't like it.
I'm dying.
Yes, I am.
I mean, we were talking about
Backside.
That's 20. And I got this
Right face down.
I got this row right here, so that's 20, or that's 30.
Wait.
Right here. Or 20.
I'll go 30. You can do the top. Right there.
Let's go.
What you got? Back. All right. Backside. Good. Back. And back. right, let's see if we can make this work.
It wasn't a lot.
Which one, you not like it?
No, I can't even click on my computer and open the file. I gotta go through Smart Notebook and then open the file through Smart Notebook.
You're having do you ever sit in that chair? Miss Wall.
Miss Wall,
What?
why did you take off Steven's name?
I told you all to go to.
And I just put another one up there.
No.
You just got so bad.
I am hungry. That's what I just jumped out.
Lay down.
Oh, how many it has it?
All right, let's look at the answers. All right, number 1. Electrons are shared. Would be what? Covalent. Electrons are transferred. Triple bond. Covalent. Molecules. Covalent. Positive and negative ions. Remember, the word ions comes from ionic, or you could say ionic comes from the word ions.
Lockdown, I'm getting in that one.
That is so random. We're doing chemistry.
I just realized I can fit in.
Number 6, metal and non-metal. Non-metal to non-metal. Within a polyatomic ion. That's covalent. All right. Trigonal planar shape. That's covalent. Triangular and trigonal mean the same thing. Some books just say trigonal instead of triangular. I don't know. Resonance. It's covalent. Remember, resonance is another way to draw the same molecule. All right. In B, I said 1 through 4, skip 5 and 6. So is F minus or F smaller? The F. Remember, F minus means you gained 1, so F would be smaller. BA plus 2 or BA? BA plus 2 means you lost 2, so it's smaller. O minus 2 or S minus 2? O, because it's bigger as you go down, so O minus 2 is smaller. All right, and K plus or Na plus, who's smaller? Na, as you go down, they get bigger. Now, part B is the periodic trend. So if you erased a lot there, that's all the periodic table stuff that we haven't done in a few days. That's half of the test on Friday. Half. All right, so if we look at part C, all right, this is, let's see if I can make this a little easier to see. I'm not sure how. Let's try this. All right. All right, let's try it this way. Now let's try it this way.
Not trying to be clear.
All right, if you look at the answers on the top row, these are 4 answers for the top row. Okay? So it says an atom of sulfur. So sulfur should have 6 dots. So there's a dot diagram of sulfur. Then it says an ion of nitrogen. Nitrogen has 5 dots. But an ion says it needs an oxidation number. What group is nitrogen in? It's in group 15. What oxidation number does it have? -3. So -3 means you do what? You gain 3. So I drew the dots in a different color to illustrate that I did what to it? I added 3. I did not mean to erase. I touched with the eraser. Yeah, but I have to go back and touch the pen because I erased. All right. All right, so I drew those with the 3 blue dots to illustrate that I gained 3. Now, for Na, just an atom of sodium. An atom is in group 1, so we get how many dots? 1. And then it said an ion of zinc. So it's in the transition elements. All transition elements have how many dots? How many outer shell electrons do they have if they're in the transition elements? 2. So it would have 2 dots. But as an ion, what was zinc's oxidation number? Plus 2. So what would I do with the 2 dots? I would take them off. So I drew no dots on zinc. That's what you do with an ion. You either add or take away based on the oxidation number. So for nitrogen, because it was a -3, I did what? I added 3. But for zinc, because it was plus 2, I took them away. Now, for the second row, those were the ionic structures that we did in the opening. All right, and those are there. You will see those in for response on the test Friday.
Like instead we just put 2 in front of the CO instead of putting CO2 in front.
On what, the product side? If you did what now?
So like you said it's NGCO2, but you wrote NGCO and you just put the 2 in front. So we want the 2 as a substrate and just write it as coefficient.
Yeah, they wrote it as a formula, so they actually told you how many CLs you were going to need in the equation, so you don't have to figure it out. That formula tells you how many you need.
So when it gives you that formula, like with the subscripts, we only put 2 elements, the 2 elements in the.
Yeah, when they wrote the formula that way, they told you how many of these you needed on both sides.
What I thought was that the prodigal reactors were 2 CLs.
No, they were just telling you how many you needed.
Okay, so if you write 2 CLs instead of balancing them.
It would have been okay. If you had written like CL plus CL on this side, I wouldn't have taken that off. I'd have given you full credit. Everybody okay with that one? All right, so the last row would be this. You don't need to worry about this bent stuff, though. That was just something that was up there from somebody who asked one year. And I accidentally hit save. Now, notice that SiO2 can be written 2 ways. It can either have 2 double bonds or it can have a single and a triple bond. Either answer would be correct. There was something similar to that on the quiz that I just handed back. I think it was P2O. Everybody drew it with 2 double bonds except Noah. He drew it with a triple and single bond, I believe. Now, for a lot of you who drew things wrong on the quiz that I returned yesterday, I drew arrows and told you what you did wrong on it. Either your total electrons were wrong, or your central atom has the wrong number of electrons.
Really? I see. Right, I didn't see any arrows on our paper. Right. On CO3, I just see an X.
Yeah, straight to the strip.
You have 6 electrons on it.
I mean,
What'd you guys draw?
I didn't know. I know.
You got 6 electrons on that. You got 6 electrons. Okay.
You'll be okay.
Yep, you're right.
Dad, look! Really hard
Great. I don't know where it came from. All right, the bottom. Number 1. What's AX4? Tetrahedral. 2. AX2E2. AX3. AX2. AX3E, AX2E. Very good. All right, on the back side, NaCl, that's ionic. H2TE, nonpolar covalent. Remember, in bond type, you cannot just say covalent or nonpolar. You have to put the two together. I'm asking for bond type, so it has to be ionic, metallic, nonpolar covalent, or polar covalent. If you just say nonpolar on the test Friday, I will mark it wrong. Okay, so nonpolar covalent.
And this is only on bond polar unite because on molecule.
Once you are doing molecule type, you already know it's covalent. Okay, so nonpolar covalent. Number 3, polar covalent. Number 4, nonpolar covalent. Number 5, I will take ionic or polar covalent. It was 1.7, so it's on the line. I will take either one. All right, and HBr, polar covalent. Now, in number 7, because they're asking for molecule type, this is what Rosanna just asked. Once you know it's a molecule, you already know it's covalent. I do not require that you say covalent at the end. You already know it's covalent. So you could just tell me polar or nonpolar. Okay? So I drew the Lewis structures here so that you know polar or nonpolar because you're following the 2 rules. Are the bonds the same? Are there any lone pairs? There is one exception, and it's this one. Oops.
Right. That makes sense. How are we supposed to know?
You would have to use your electronegativity table. I'm pretty sure I did not put any exceptions on the test.
So wait.
All right? So SEO is polar. It has the same bonds in a lone pair, so it's polar. ASCL, same thing, lone pairs. All the bonds are the same, so it's polar. And then bonds are the same, but there's lone pairs, so it's polar. Bonds are the same, and there's no lone pair, so it's nonpolar. And then pH3 is the exception because it's 0 when you subtract. Okay, questions? Any issues with what we've done thus far? Because so far all we have left are to talk about properties and bullet point.
So whenever the exceptions, just to make sure we don't miss any of them, we should always check their electronegativity.
And make sure it's not 0. The only time it would be non-polar if it has lone pairs is if you subtract and you get 0. I'm pretty sure I didn't put one of those on the test. I'm 99% sure.
Okay, but what if you did, and then we didn't know that it was an exception?
And I guess you're just out of luck, but I'm pretty sure I'm
We're just
right.
gonna have to get a 99.2.
Annabelle will have no sympathy for you if that's the case. None at all. All right, so let me see if I can get rid of this.
Wait, so we can use our electronegativity sheet?
I'm going to give you an electronegativity sheet. You get the electronegativity sheet on my test. If the state wants you to do any of these things I've taught you, they will put the electronegativities in the question. Okay? Because they're not going to give you an electronegativity sheet, but it will be part of the test question. All right. No, I do not want to say that.
You want some?
What? Yeah, it's on the hallway across from Miss Bostic. You know where Miss Thornhill is beside Miss Bostic? Yeah. It's across from Miss Bostic. You're welcome.
You randomly walked into math class.
All right, somebody tell me where we were yesterday.
Why do metals come out? Alright, we saw we were talking about how metals are made.
Okay, I'm looking at Sarah. I'm good. All right, so we have a couple lines between what we did yesterday, just in case something occurs to me and I come back to it. Okay? So leave a little space. Never know what might happen.
Well, Miss Paul, you don't have much time for it to reoccur to you.
You never know what's going to happen.
Yes, don't let it.
So, I kind of forgot to tell y'all this. So, it makes it
Good luck.
And
questions on it and I forgot. So, good luck.
So you just found it in your.
No, then that's freebies.
No, there are no freebies.
You didn't know that.
That's because, that's why I gave you test corrections.
Try your best. Well, there is another correction.
All right, so we need to talk a little bit more about ionic bonding and how their properties compare to covalent bonding. All right? Oh, sorry, metallic. We're doing covalent last. All right, this open door thing is going to drive me crazy. All right, that does a little bit for that. All right, let me flip back and see if I forgot anything under metallic.
I'm gonna borrow your whole punch. And I'm taking it to the dog.
Okay.
Annabelle.
I don't see anything that jumps out at me. We didn't talk about their properties. We only drew the structures.
Oh, so properties are right.
Yeah.
Alright, there you go.
All right. So, how do properties of ionic bonds work? All right. So we talked about some properties yesterday of metallic bonds. So now we're going to talk about some properties of ionic bonds and covalent bonds, and we're going to compare the three of them today, and particularly look at Boiling Point to end our discussion of bonding. So, I need to draw a really ugly picture. And it's always bad, and it'll be bad today, and particularly with this god awful.
What does it look like?
But like up here.
You know what, that's fine.
Well, it's not bad.
I don't know what it is anymore.
Well, it's gonna be
Mine was done before I even got to school.
Not bad, Miss Wall.
No, no.
It's still bad.
It's not that bad.
Still bad.
I'm not like you.
Okay? Now, the whole thing is called a crystal lattice. Okay? A crystal lattice is the orderly arrangement of crystals. Now, inside the crystal lattice, there are individual, inside the crystal lattice, there are individual unit cells. All right? The unit cells are the simplest crystal that tells the structure of the crystal lattice. So, if you see one unit cell, and you know my unit cell is a diamond, you should know the rest of the crystal lattice will all be what? Diamonds. Now, when we talk after we do the gas laws, and I said we're going to come back and talk about solids, liquids, and gases, we will talk about the 7 crystal patterns that there are. There are 7 types of unit cells. You're not going to have to memorize what the 7 types of unit cells are or anything like that.
But why are we learning about crystals? Like, what is it
Because
relate to?
ionic bonding has what kind of properties? Ionic bonding has crystals, which are going to dictate what types of properties they have. For example, our ionic bond is going to be conductive.
Are you gonna bring animal crystals?
Do I have what?
Crystal.
I have some rocks back there.
I love it.
I mean, I can bring in my engagement ring, but I can't wear it currently.
You can't wear it.
No, I can't wear any of my diamond wedding bands since I broke my wrist.
Right.
What?
And I broke my wrist last summer.
Is it too heavy?
No, it's not.
You wearing a ring?
Because my hand swelled, and they told me I'd have to wait at least a year to have them resized.
Oh. Wait, what are you trying to bring in?
I said, I have a crystal. I can bring in my engagement ring or my other ring, but I can't wear them right now. I have to have them resized.
Crystal?
But they told me I have to wait at least a year. So
Crystal, how much longer do you have?
July.
Joyce.
Yes.
I ain't growing up.
Fortunately, I wasn't wearing it the day I broke it, or they had to cut it off.
Hold on. Wait, how did you?
How did I break it? I haven't told you all that story.
She
No.
fell on the sidewalk.
Oh, yeah.
See, I live in It wasn't a real sidewalk in my defense. It was a ramp that was not marked.
Did you cry?
No, I didn't.
Did you just go, ah?
She probably cursed a little bit.
I did use a dirty word. So a nice man helped me up, and I drove home where I called the doctor. And
Wait,
went
what
in.
was your left hand?
Oh, I was in Greensboro.
You had a drug.
No, they go to the doctor there.
Because my insurance is terrible, and I was not going to the emergency room and paying. It's $300 to walk through the door plus my deductible.
Yeah.
So
Mama, she was hurting.
I was, but I drove home and then I went to the doctor here and paid a $40 copay, where they then sent me to the emergency room, and I then didn't have to pay that. It would probably cost me $600 out of pocket initially. They're asking why I didn't go to the hospital in Greensboro when I fell off the
I had to do
sidewalk.
that when I had a problem.
I told you it would cost me a fortune. It's much cheaper to drive home, go to my doctor, pay $40, and then be sent to the emergency room.
I'm gonna have to come up with a gang that way I gotta go to the hospital. I'm not paying that.
Of course, I got the
Being a
first
gang.
EOB from Larry's eye surgery. I almost died. I almost fell out in the kitchen. What do you think it cost?
Let's see, well, an MRI was separate.
6,000.
So it's
Yeah, I was about
gonna
to say 6,000.
be.
I just told you I almost fell out in the kitchen.
I'm going 10s, 20s.
How much was it?
Y'all aren't even in the ballpark.
$50,000.
The first EOB was $83,000.
Oh shit, no. I'm not paying that.
My dad was passed out. Like, if that was laying, he would have passed out.
I almost died in the kitchen. I was like, huh? I hope so. I'm like, Quick Cars loves me. No, we ain't paying that one either. Put me on payment plan. Y'all got no chance.
Hey, don't you?
There's ridiculous and stuff like that cost that.
Where did Shelby want to go to college?
She's not going down. We gotta buy an eye.
Put all that on the FAFSA. Put all that on the FAFSA.
She can't afford it. She can't go.
ECCC is fine. Tell her about the FAFSA.
Yo, that is 80,000.
Yeah, that was the first EOB.
That's a house.
I thought I was bad because I had to pay $3,000 for my car.
Now, granted, a lot of that will be covered by insurance and the rest of it,
I
but
hope so.
our part will probably be close to 10.
See, that's why health insurance should be free. There's no reason to be paying that much money that's worth a house.
Yeah, our part will probably be close to 10.
That's like not even like a
Yeah.
house. It's like a decent house.
The left is broken.
Not an apartment.
Yeah, I can wear my watch. It's
adjustable.
It's adjustable. It's a little bit deformed. I still can't make a fist fully. This is about all I've got. The grip is not there. Some days if I try to open the doorknob, I can't grip the doorknob.
Also, if somebody try and box you, you might get beat up.
That's all I know.
I don't have full strength. All right. Huh? He's a truck driver, so having vision is important. So we don't have an option. He had to have his eyes fixed. All right, moving on. Everybody got it?
Miss Paul, I like to learn about your life. So did Shelby like? Did she
What?
want to go to a college?
Yes, she's still going to college. Boy, we're just gonna be in debt the rest of our natural lives.
That is insane.
All
Where
right.
does she want to go? Like crazy expensive school? Like
No, she's going to an in-state school.
oh, I was about to say.
She would like to go. She's thinking about a private school too, but we'll just see. She'll be paying student loans the rest of her life.
Shelby.
Yeah.
Do you hear that Liam got a full ride to Carolina and Daniela got a full ride to Duke?
Yeah, cool.
That's insane.
All right, moving on.
What?
So the reason that we're talking about the crystal lights. All right, moving on. Crap.
You know, mix it up this long.
I know.
Liam, you got a full ride to Carolina, and you got extra $7,000 a year. Oh, Liam, bless you.
Next, Charles' brother.
Yes.
All right,
Charlie's like, I'm gonna do that.
so moving on. So ionic compounds, because I just told you they're crystals, are going to be solids, right? So if they're going to be solids, all right, and they're going to be crystals. What kind of properties are they going to have? All right, will they conduct? Think about things we talked about yesterday.
Are they all crystals?
All ionic compounds are going to be crystals.
So everything is a crystal?
They're all crystals. All right, so let me give you some examples.
They're not malleable.
All right, NaCl, salt. I don't know why that black line is there. I got nothing for that. All right, ice. Yes. All right, ice would be one. Emeralds.
He's saying you better say that. He said, I am not acting right until I get paid. Wait, it's not.
All right, diamonds.
What's gonna do for the board?
Did I shush?
I think it's no.
There's no telling what's wrong with this thing. It's possessed. All right.
$4, y'all. $4. Pay 50 cents a day.
No,
It's not more.
It doesn't matter. Hopefully, we'll be able to get it maybe in the next few weeks.
Right. I'm paying
Now.
somebody else.
Shh. So, given these things, what did we say yesterday allowed metals to be conducted?
Electrons are freely moving.
The electrons are freely moving. So, are the electrons freely moving here? No. Okay? So,
Unless it's gonna give me like a free test for it.
So are you saying like if it's in a crystal, then it's not gonna be a good conductor?
Really?
so, now the electrons are not really like that, but the reason I drew them there is to illustrate something. Are the electrons freely moving in this structure?
No.
No. Okay? So the electrons are locked into position. Okay?
Does it matter where those E's go?
No, it doesn't. It's not drawn correctly. All right? So the electrons are locked into position. So if the electrons are locked into position, can an ionic crystal conduct electricity?
No.
No. Okay? And it doesn't matter where you put the E's. So,
all ionic compounds are freely moving.
yes. So these are not conductive at all. Okay? They cannot conduct. So what else will they not be able to do when compared to metals? Are they malleable?
No.
No. So they're not malleable or ductile.
So what are they good at?
Insulation.
So what word could we use to describe ionic compounds?
Hard.
All right? They can be described as hard, yes. All right?
Oh, there she go.
I know. Go figure. All right, they're hard, and what else? What's a B word? Think about like
Boron.
no.
I was gonna say something else.
If we hit an ionic compound, yes, I heard it back there. It's brittle. If we hit it, it's going to shatter.
I thought it was beautiful. So said that.
All right? It's brittle and it will shatter. Yes. Ductile. Okay, now. Now, it's also the second strongest bond of, guys, those who are talking, stop. A, it's rude to be, and it's also incredibly distracting to your classmates. Alondra, turn around.
Shatter
All right.
or shelter?
Shatter.
So they're hard, brittle, and can shatter easily?
They can shatter easily. All right, and it's the second strongest bond. So when we talked about yesterday, the metallic bonds being the strongest, what do we say about their boiling points if they were the strongest? They would have the highest boiling point.
But wait,
So where will ionic fit in terms of boiling point? The second highest.
But how are you going to be hard, but also be able to shatter?
Great question.
Like I'm confused.
Because if the,
So it's like glass.
yes,
Okay.
glass is hard. But if you hit it with a hammer, what's going to, it's going to shatter. The crystals are locked into position. So as long as you don't break it, it's fine. But if you try to shift those crystals, what happens? They're going to shatter. Okay? Now,
Man.
can,
Happy birthday, Warlock.
Appreciate it.
Happy birthday.
oh, you like the black lines when I write? Now we have black lines just
Don't
appearing
steal the pen.
like it's possessed.
I won't.
All right, now why is it not doing anything?
Yikes.
Oh, you can quit playing with you this morning. That's how you get
Go still miss that one still that shit.
Hers don't work at all.
Oh,
She just uses it to project.
well,
I'm gonna go get one of them school laptops.
I can't even find the mouse.
I'm gonna like, there's this girl, like, a pinwheel kid or something, like, trying to look at it with the things,
Where is the mouse?
I'm making a pinwheel. $4, Oh, before I do, for
I don't need a board, I need a computer. I don't even need a computer, I need $130 to buy the new.
Alright, I'm gonna make a subscription right now.
We don't need a GoFundMe page.
Yeah, I'm gonna go fund me account. I'm gonna say my Venmo is. And then I'm gonna keep all the money. Go fund list. We can fund it and she was teacher of the year 3 years. She deserves this before she retires.
Here we go, I found the mouse.
No, it's gonna be like, it's not fair. Right. It's not fair. If you want to do this, why can't you do it all the other teacher? What is going on?
I don't know.
What is that? Canceled. That's over. It's canceled. What was she doing? The eraser doesn't work and it's just marking out. You're kidding. You gotta be on a racer. Go on a racer. That's when it was marked. Move on. Make $130.
Alright.
Right?
Alright, can we make an ionic compound conduct?
Make it break from its natural state.
Alright. What do we have to do to make it conduct?
Break it. Shatter
We
it.
have to make the electrons move. Alright?
So break it.
So let's shatter.
Alright, so I hear shattering. So if we take something, we break it with a hammer or with something, will the electrons be moving or will we just have a bunch of broken pieces? A bunch of broken pieces. Alright, so that's not gonna work. What?
We heat it up.
Alright?
If it's sort of like
You can
glass,
melt
you know what the
glass.
shape of the glass, yeah.
No,
Alright. You can heat it up, which is called the molten state. Now, I don't have any way to heat like salt or something to make it the molten state. I don't have any way to make it that hot. Okay, but I do have a way to make the Bunsen burners aren't going to get hot enough. All right, so
I mean,
we can do it in a way here that's much easier than making it hot enough to melt it. So how can we do it even in here? Don't make the electrons
You can
move.
eat it.
Space for us.
All right, something easier than stomach acid. Something easier than stomach acid. What? You don't need acid.
You can.
What else can we do that's easier than using an acid?
Rub it.
Sure.
Throw it in the air.
Break it.
Yes, at this point. Go. Wait.
What else is easier? We just need to make the electrons move.
Make it cold. Set it really hard.
Move it like that. Move it really fast.
Set it on. Put it in sunlight.
Yeah, put it by the gas.
No gas, no sunlight, no throw it in the air.
Can you put it in water?
Where does it start with?
What? I heard it.
Put it in
Water.
water?
Yeah.
Put it in water.
Because it's gonna dissolve. Yeah. Hey.
Dissolve it in water. All right. If you put it in water, all right. Let's just say we take salt.
Salt water.
Exactly. All right. If you put salt in there, you make sodium ions and you make chlorine ions. Okay. The ions
It's basically the ocean.
are the moving electrons. How many of y'all get in a swimming pool in the summertime? What do you have to do every time a storm comes up?
Get out.
You have to get out. Because if lightning strikes the water, you're dust. You're going to be electrocuted. Okay? Because what do they dump in the pool every single day? Chlorine. That chlorine dissolves in the pool. Those are moving electrons. Okay? They carry current all over that pool.
Get out on the ladder. She got out on the ladder.
It's the truth.
Don't get out.
She's 12 years old. Her name was Lauren Cecil.
Yep.
She was in the pool when it was storming and it electrocuted her and she died in the spot.
What you doing? What you doing in the pool?
Well, they had just blown the whistle and like they say get out on the wall and so she got out on the ladder and then it electrocuted her. She died.
Okay? Swimming pools are filled with chlorine. Chlorine are moving electrons. All right? Electricity flows through those. First of all, water is a natural conductor. All right? Not because water itself conducts, but water breaks into ions. All water does. Okay? It doesn't matter if it's swimming pool water, if it's, are y'all listening? Stop talking. Or if it's fountain water, if you buy high dollar water. Yes.
Can I have Rosanna Razura Tagadas?
Yes.
Right.
All right, so it doesn't matter what kind of water you're talking about. All water breaks into ions. But in a swimming pool, we do what? We throw in all kinds of chlorine to kill germs.
And kids see.
All right? Yes, but hopefully not a ton of pee in the pool.
Miss Wall. So wait, does electricity attract to something though? Metal.
Well, electricity will flow through anything that has ions in it.
So it
Okay?
doesn't flow through rubber.
Water does not go through rubber because rubber's an insulator.
So what is it made up of?
What?
Rubber.
Electricity will flow through a metal or a conductor. Water is a conductor.
I'm saying, what is it made of?
It's made of electrons.
Oh.
Electricity is just
That's why
electrons.
Mr. Electron, what's his name?
Yeah.
Mr. Electron. Yes.
Electricity is just electrons. So it just flows through those because they're electrons. Okay?
What about the Samsung?
What about what?
Lightning on it.
Same thing. It's moving electrons. Salt water has sodium ions and chlorine ions.
So as long as it's the ocean, right? It acts
You would not want to be near the lightning strike. Now, over time, it's going to dissipate if it's a good ways away. But, you know, if you're in Myrtle Beach and you're standing in Florida, you're not going to be electrocuted. But if you're close by where the lightning strike is, yes, same principle.
Fishy.
reminds me of like walking the walk.
Why do I hear people over there on that side of the room talking?
I actually know a lot of people that get electrocuted. That's sad.
Hey,
Huh? Oh, I was talking because like this one time some like little storm, the guy was like, "Get out!" And then we all say, "How? Water, water!" And then and then lightning hit, and I was like, "Oh, look, that's pretty." And then something touched my foot. That way, I was like, "Oh my god!"
You got that because you ended up looking.
It's not a very good way to go.
Lightning petrifies me. I drove the other day in a storm. I had my sun visor down, so I could not see anything but the ground.
I can barely see the road.
You don't drive in the storm then.
I'm ready to go to work. I had to go to work, but I was like, I'm not taking it. Like, okay.
Let me see if I missed anything.
You better not have. Come on now.
Oh, I didn't do lattice energy.
Is this new or is this?
Yeah, it still goes with what we're doing. Lattice energy tells the strength of the bond in a crystal. So,
My notes are so messy now.
sorry. Let me see. Let me get real numbers instead of making up junk.
It's been the same thing for so long.
I think class should just be canceled until we get the board.
I can't fix it. It looks terrible. Still doable. It just looks bad.
Make that GoFundMe.
There we go.
The pinwheel. And I'm gonna say complete the pinwheel. And like, it's gonna either have like 3, 4, 1. You get Miss Quality board. It's gonna have 28
We saw being
slots.
more like.
I don't need a new board. I just need a subscription to get the updated front notebook.
They will give it more.
Right, we'll get more money. I guess.
We gotta blow it out!
They
It's like edit where you can't see the
the wall.
All we need is the updated smart notebook.
So what if we get more money than it is? So we can buy food and have a party.
Now, if we look at these three numbers, all right, and these are 3 crystals, just 3 ionic compounds, what can you tell me about the strength of those 3 crystals? Which one would have the greater strength? Okay,
Where'd you get the numbers from?
I just got them out of another
Are
textbook.
we supposed to learn what
No,
that
no, I do not want you to do anything with these numbers. I just didn't want to make up junk. All right, this tells us
Right on the board.
that this is a stronger bond
I need a blackboard.
and it's a stronger crystal. Why?
Because the numbers higher.
That's right. It has a higher lattice energy.
Miss Wall,
What?
before class is over, I need a picture of you drawing on the whiteboard with the blank smartphone behind you.
Okay. Now, the same concept is going to be true very shortly when we do this with bullet point. All right. So this would be a weaker lattice energy.
Which means it'd be able to break easier.
That's right. So it's going to break easier.
And boil faster.
It's also going to boil faster.
And heat faster.
So it's going to have a lower boiling point, which is what we're going to talk about towards the end of class. Okay? Because we're going to tie this into boiling points after a bit. Okay? That's where we're going with this is boiling points. All right? So lattice energy tells us the strength of the crystal. So LiF would be a stronger crystal. Li would be a weaker crystal because it has a weaker lattice energy.
Do you think they did this in like jewelry stores and they're like, well, this has an LI of this?
No, they actually figured this out. If you were in AP, you'd have to know why the lattice energy goes up or down. And I would teach that, but I'm not doing that anymore. I just wanted real numbers instead of making up numbers. All right, are we okay with ionic and their properties?
How is it only 11 o'clock?
Because it is.
The time's on my phone, so like,
Yeah, I hate this topic. I wouldn't teach it, but it's,
oh no.
and I'll be honest with y'all, this is one you'll likely see on the exam.
So if it has the
one I
higher
don't
point,
need.
does that mean it grows slower?
No.
It takes longer to boil, yeah.
Yeah, we all.
So, who right now should you know is conductive?
Huh?
Who should you know is conducting?
Me.
Metals. Who should you know will conduct in solution?
Crystals. The ionic.
Ionic will conduct in solution. Okay? What does in solution mean?
Water.
Dissolved in water. Okay? All right, so the last one we have to do is covalent.
What are we doing after this?
We're going to add in boiling point. All right, so covalent compounds will not have moving electrons. They will not form ions. So, what does that tell you about their ability to conduct?
Terrible.
They're not conductible.
That's right. They will not conduct electricity. They will not conduct electricity. Covalent compounds cannot conduct. You can't make them conduct. They will not form an ion. They do not have any moving electrons. So you cannot make them conduct electricity. Okay? Now, are they going to be malleable and ductile? No. Most of these are going to be liquids or gases. So, they're not going to be malleable or ductile. Now, I'm going to give you a new vocabulary word. These are going to be what we call volatile. These evaporate
Sounds like volatility in Harry Potter.
easily. Just not a, I'm not a big sci-fi fan.
What's your favorite book
It's
series?
not sci-fi.
What's your favorite book series, Ms. Walls?
I really like the J.D. Robbins series, and I really like Marie Force.
Are you like Nicholas Sparks?
No, I will not read anything that is sad, and he is way too sad for me.
I don't know his books.
Nobody else knows
Oh,
sci-fi.
All right.
I read one when I was in Belize.
What'd you say? Say it again, Alicia.
Miss Walsh.
What?
Wait, so you like not like sci-fi shows either?
No, not really.
So you don't like Stranger Things, The Umbrella Academy?
What do you watch?
Them shows?
I don't remember the last time I had the TV on.
Oh, yikes! What?
Right, but how much?
Other than news, I watch news. Now,
You don't watch anything on Netflix?
I read almost all the time.
Wow.
Everybody else in my family watches stuff, but I don't. Now, if covalent is the weakest bond, what did we say this was going to translate into?
Boiling point.
All right, so it's going to have what? Low boiling point.
Yeah, girl.
All
It
right,
looks like
so
something right now. I don't know what it is.
let me see if I missed anything. Nope. All right, so everybody got what they need so far.
Yeah, I got this.
So if we look at what we've done, we know metallic has the highest boiling point, right?
Yeah.
So that's greater than who?
Ionic.
Okay. Which is greater than who?
Yeah,
Covalent. That will have the lowest. Is everybody okay with that so far? Because we have our last thing to do, and then we're doing bonding.
Let me write that in green.
And that's all for Tennessee.
Yeah, we gotta do Van der Waals forces, and then we're finished.
What is that?
I love made-up words.
It's a man's name.
A man, dang.
He Russian?
No, he's Austrian. I think he's Austrian. I'd have to look, but I think he's Austrian.
I don't know American. Like, that's-
Very few of the guys we study are American. You're just so bad. That's a little harsh, but. All right, we're there? All right.
Okay, we can have that. You, and you have to
That's what now ladies.
You're getting on me, Miss Wall. Tell me stop.
That's kind of harsh.
It's not harsh.
You gotta be
She
sitting
just
there.
normally has her hair down, so she had it pulled up, and then you
I'll
can
have
go
my
to
wig done
tennis.
next week.
With what? Is it double A?
Yes, double A.
You mean,
All right. So Vanderbilt forces, first of all,
Well, their husband is last name Wall.
yeah, but it's not spelled that way.
What did she say, Lil?
All right. Vanderbilt forces, first of all, are attractions between
Hey, what's up, man?
covalent molecules.
Hands down. Miss Wall, she's taking it to social media.
Give her a rest.
Sorry, it's funny.
Now, are van der Waals forces going to apply to metallic or ionic bonds?
Yeah.
Both.
no.
No.
Say
These
what?
are only going to apply to what?
Covalent.
Covalent. Okay? So in a minute,
In a minute.
when we come back to this, am I going to put this with metallic or ionic?
No.
These are only going to be, I don't know how I did that, down here.
Between what?
Van der Waals forces are only going to be down here.
Between covalent.
Okay?
Okay, thank you.
I'm coming back to this. Now, there are 3 van der Waals forces we have to talk about. The first one is called dipole. Dipole. All right? And I will tell you now, for those of you who've told me that you will have to do this in college, this is way oversimplified, but you don't need all of the details for this class. All right? This is an attraction.
Way oversimplified.
Yes.
So it gets worse.
If you have to take it at another level, yes. Between polar molecules. Number 2.
You said there's only 3, right?
Yep.
Okay, so one more line.
Hydrogen bonding is an attraction between,
2 hydrogen molecules.
nope, hydrogen
And oxygen.
Okay, I can't read that.
Nitrogen. Fluorine.
and a lone pair. I do not know why I have this weird line.
We don't need that.
And I can try to make the
I can
line,
barely see.
You just lied.
okay? When I try to erase, the line doesn't go away.
No.
Because I don't type very fast.
Do you have an emu?
Okay.
What? No. Board camera? The Elmo, not the emu. The emu. So
It's like, I'm thinking that's an animal, like a ostrich.
Yeah, that's it. Because you could like write it on printer paper and just like keep on, throw it away.
Right, I was that.
Okay.
That's what it's just said. Okay. It just like writes on paper and like, that's what it started as. He like has these kids like camera thingy. Yeah. That's
All
bad.
right. The last one is a London dispersion force. And it's an attraction
Maybe you try.
between non-polar molecules.
What does the second one say?
It says an attraction between hydrogen and a lone pair. Not that you can really read that. It's an attraction between hydrogen and a lone pair.
No. Look how close this paper is.
Oh, did you know the first images of a black hole are coming out today?
I saw that pop up on my phone.
Because she was
Wait,
Let's look at
That's
we don't know what a black
bro.
hole really looks like, so they had to make an Earth-sized telescope to graph it.
Look at it.
That's terrifying. Oh.
Oh, a black hole.
Now, how are we going to know?
I didn't say how.
Guys, I realize you're tired. You want out of here. I get it. This is not my favorite topic either. Now, with dipole, how are we going to know if something is a polar molecule?
We do the thing that we
We do
did
a
the
thing
other
and
day.
we
Can we subtract or do we have to draw a Lewis structure?
Lewis structure.
Gotta draw a Lewis structure. Okay? So,
How do you?
Wait, why can't we subtract?
because it says right here. It's that word.
Younger liquid went out.
Oh, wait, covalent.
It says molecules. Doesn't say bond.
Joyce.
It says molecules.
Don't throw it.
Don't throw it. Walk it over there, please. All right, so here's what we're going to do. All right. I should have just scratched it out.
I believe she had to repeat it 50 times. And then when she was saying it,
All right, rank the following in order of
Importance.
increasing bullet point. Okay, increasing bullet point. So if we want to put these in order of increasing bullet point, we need to know which of those three is going to be the highest, right? So
That's why you got your steps in today.
all right, the mouse is going again.
Can
Press
you
the
use
stick
stick on the
on the
keyboard?
side.
Use your up arrows.
I just need the mouse to appear. Where is it at?
There it is. You just there.
There it goes.
Sorry, I'm kind of went up a little bit.
All right, Annabelle.
What?
I want it in advance.
I was, yes.
I should be able to just hit. I should be able to click these.
Hey, quit touching that.
Yeah.
Huh?
You have a review test today?
Friday.
Is that it?
All right. I don't know if we have it or not, but let's try. All right. Which of these three do you think is going to have the highest bullet point?
Dipole.
That's a good guess.
Okay, the third one.
Hydrogen bonding has the highest bullet point.
Why?
It just does.
So why didn't you put that one as the first one? That'd be easier.
All right. I don't know. That's the order I thought of it in. All right. The lowest bullet point is London dispersion. Okay. So
That means it's bond is stronger.
that means it's a strong. It's not actually a bond. Think of these as magnets. Okay. So they stick, but they're not actually bonded together. So if I go back to, okay, now I can't unwrite on the page to get to clicking. Okay.
Escape.
So if I go here, all right, down to here. All right, so we have Metallicus.
I thought it was hydrogen.
All right, so if we have Metallicus the highest, and then Ionic is next. All right, and then covalent. Now, if we have more than one covalent bond, who is the highest out of the covalent bonds?
Lowest.
All right, would it be dipole? Would it be hydrogen bonding?
It'd be
Or would it be LDF?
It'd be London to person.
It'd be hydrogen bonding.
Damn.
Watch your language. I think I'm in fourth period. All right, now, who's the next highest?
The
Dipole.
the London.
And then who's the lowest?
London.
They go to London.
Okay, so see if I can manage to change the color successfully here. All right, so this is the lowest bullet point, and this is the highest. boiling point. Okay? Now, we want to try to do this with real compounds. That's the goal.
Well, we don't even know what this is about.
I don't even know what board.
We understand that, we don't know what it's about.
Well, you better get.
That's okay.
Wait, that's not a newsflash.
So you need to get it together for the board.
This board and I are not getting along.
David? Ow!
Life is hard.
It's
It
not
is hard.
Steven, it's just software protection.
Alright, so let's say that we have H2O, we have Fe, we have CCl4,
Okay, wait.
we
I
have
guess on that.
KCl, and we have SO2. Alright, those are our 5. And we have to put them in order.
Can I give it a
based
shot?
on- You want to go lowest to highest or highest to lowest?
Highest to lowest. Let me give it a shot.
Alright,
No, 'cause look, I think I know.
so we're going from
Highest to lowest.
highest boiling point
BP.
to lowest boiling point. Alright, that's our goal.
Let me guess.
We don't guess.
No, I think I know the first one. I think. Wouldn't this one be the first one because it has hydrogen in it?
No.
Hydrogen. The second. This.
It goes to the noble gases.
Alright, so what's the first
Oh,
thing
so-
we need to figure out?
What are they?
What are they? Okay, so the first thing we need to know is what are they?
Yeah,
Caleb,
go
put your
back
phone up.
up. I can't see over your big head.
Caleb, put your phone up. This is why some of y'all don't know what's going on in here. So, what is H2O?
Water. O's.
Where? That is a brilliant deduction after 12 weeks in here. Covalent is the answer we need.
How do you even
Okay.
know it's covalent?
What?
That's all right.
Correct. It's 2 nonmetals.
Yeah, I can't
Alright.
remember.
So, what is Fe?
Iron.
It's metallic. How'd you know it was metallic? It's just one metal. Okay? Now, y'all say my handwriting's bad.
Metallic.
That's-
The next one is covalent.
All right, how'd you know that?
Because they're not metals.
They're non-metals.
Then it's ionic.
All right, then I hear it's ionic. That was better.
That was connected.
All right, and then I heard ionic and I heard covalent. All right, are we okay with that?
Yeah.
Now, based on that, you should be able to tell me the 2 highest. All right, go back a couple pages.
It's ionic, metallic.
All right, so who is the highest? The
Metallic.
metallic. So iron is first
Iron. Oh, yeah.
because it's the highest, and we said we were going highest to lowest.
Why do I keep writing I? Oh my god. One there.
Touch the
The
pen.
highest, so that'd be deep.
Why don't you just write Fe? Okay,
Oh.
write them in a list order. So Fe to.
So wouldn't that be decreasing between highest and lowest?
No.
Well, y'all said to go from. Well, I had said increasing, but Annabelle changed my question from highest to lowest. So we're
How?
going Fe to what's next? KCl. Here, let me do something.
So they have to figure out what
I really
type of
like writing on
bonds
this.
those boys are.
All right, so now we have to do the covalent. So what did I say covalent had to be? Now you have to figure out who's hydrogen bonding, who's dipole-dipole, and who's LDF. So now you have to do what?
Look at their numbers.
Look at the Lewis.
You have to look at the Lewis structures.
Oh.
Okay?
Well, we can say H2O, water because
Right.
Now, not all H2Os will have, or all hydrogens will have lone pairs. Just saying. I can think of a couple compounds that have hydrogens and no lone pairs.
Without, how would hydrogen even have a lone pair if it only has?
What was the other compound I gave you? SO2.
SO2.
All right, there's our, other than that weird purple line. All right, there's our three compounds. So what can you tell me about H2O?
It does.
It does have a lone pair and it has a what? So if it has a lone pair and a hydrogen, it's what? That has hydrogen bonding. Okay, so that's hydrogen bonding. Yeah, you can write it if you want. All right, what's the SO2? Is it polar or non-polar?
Polar.
How do you know it's polar?
It has two dots on it.
It has the two dots on it, so if it has the two dots, it's going to be, okay, so it's dipole-dipole or LDF? It's going to be the dipole-dipole.
So wait, Miss Block.
Yeah?
For the hydrogen bonding thing, it just has to have lone pairs in general in the compound?
It has to be on the central atom.
Okay.
All right, and then CCl4 is what? Polar or non-polar? Non-polar, so if it's non-polar, that has to be what force?
It's that London guy.
That's the London guy. So that means it's London dispersion. So that tells us what? Who's the strongest out of these three?
H2O.
So this one's the strongest. Who's the weakest?
The London guy.
The London guy.
Is it like typically London's gonna typically be the most weak all the time?
London is the weakest all the time.
Okay.
It's not typically, it just is. Okay?
And is
So-
hydrogen always the
Hydrogen is always the strongest.
Okay.
All right, so when you go back to your list, all right, you go back to Annabelle's list, that means who comes after KCl? The strongest, right?
hydrogen?
So water is the hydrogen. Who is the weakest?
CCL.
The CCl4, the LDF, and that puts SO2 right there in the middle.
So wait, what if you get? What if
It
you
looks like a 990 race, but
Raquel
I'd
has a question.
make a mess. Raquel.
How do you know SO2 is a dipole by looking at the unit structure?
Hang on one second. Patricia, move up here. Nadia, move over there. Raquel. What was your question?
How do you
Patricia.
know SO2
No.
is a dipole? When you said it was polar.
Oh, because it had a lone pair on the central atom, and it had bonds for the same. Because the bonds are the same, the dipoles are equal, but it had a lone pair on the central atom, so the bond angles not be the same. But because that lone pair is there, that's meant polar.
And you
Let me
said
go
it-
back.
But it was, well, why would it be a dipole?
It's the polar molecule.
Because the definition for, I can make it go back.
Attraction between polar
Probably can. There we go. Yeah. Polar molecules are dipole-dipole.
So we need to know the bond angle.
And unless I tell you otherwise, consider those your permanent seats. Okay. Okay. Yes.
And you said we need to know the bond angles for Breda.
Yes.
So
Yes.
wait, what if you have two that are the same?
What if I have what?
Is it-
To the side?
Like two of the compounds, what if they both end up being like London? Is there one?
Oh, I will not do that to you.
Category?
I will not do that to you. You will have one of each. Okay.
So we just gotta know, we just gotta figure out which ones they are, then we
Yes.
should know the order.
Yes. Like I will not give you two metals. I will not give you two onyx. I will not give you two dipoles. It'll be one of each. So if you get two metals, you should know you did something wrong.
And when does this unit start? Look for
Beginning of the periodic table. But you might have some overlay into the last unit, like if I give you something that's a period or a group, even though we did that in the last unit, I would still expect you to know how to do that.
Okay.
Or if I gave you shorthand, I would still expect you to be able to read shorthand,
Okay.
okay? All right, you think you can try one on your own?
Let's go, Miss Long, failure is an option. And Kaya, you don't fail.
Nikaya,
Okay, please shut up, because I am failing. Try again.
maybe.
I'm not sure what she's failing exactly.
Okay.
What are
Alright,
you feeling?
So let's do increasing this time, okay? So this time we're gonna do increasing. Alright, we're gonna do increasing boiling point, and we're gonna have, let's do NH3, let's do CH4, let's do,
That's ammonia.
very good.
Nickel.
You did Joseph homework?
There.
Is that PCL3?
Yes.
Okay.
Do those. That should be an easy one.
It is.
Should.
Should be. Should not cause
I'm
any,
so glad you understand.
any issues.
Huh? I'm glad you understand that.
I'm not here ready for y'all.
Oh, those aren't on here, are they? No, they're not. NI is.
And I is because it's an element. Rest of them are compounds.
Well, I have to draw the little picture.
Nitrogen is.
Well, this is not full, right?
What? Got 2 more left.
Oh. I'm sorry, no, like.
8 in the other box.
I was wondering what you guys.
Got them drawn? Right?
How do you draw?
No, I haven't made it yet.
Shoot somebody.
Like, wow.
That's what I mean, sorry, but you don't know how to get it.
They're both a non-metal, so.
Am I have a question?
I don't, it's hard.
What do you mean?
What's wrong?
I don't know how to do it.
You know, like, covalent
Huh?
are hydrogen is never.
It's also, now we got 4. Where's the
Oh,
one?
my God.
Ionic.
Right, so you got 1.
And then metallic is just the element.
So which one do you like? I don't know whether it's on or covalent.
But I accept, I
All right, what's the definition for ion? Yeah. One of these elements.
But it's
So how do you-
That's all non-metal. H is the non-metal, it's the exception.
Well, what about this one? Oh, it's this one.
It's all fine.
So you can go over it now, we can be.
I can go over it now, you're
It is
confused.
hard labeling, I don't know. I don't know.
Look, this is under.
No, yes, yes.
No, what?
Hydrogen lumber. I mean, there's dipole also, which also has to be on.
Sometimes you get regardless. For the exception. For the exception.
No, it's got hydrogen lumber. No,
What if, like, okay, across the board? Okay,
That means ionic. It has to be
well,
like behind the staircase. Just behind the staircase, and it's like a floor.
So I had COVID.
Oh, wait, it's from. So those would be the pieces.
And then you have to figure out over the covalent, which one of the four things.
not dipole. Yep, not dipole. Is it polar or dipolar? It's dipolar, so it would be. Yep. Yep. Yep.
Watch this quick.
Yep. 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 Correct. Yep. Like we drew yesterday, you gotta figure out the dipole. London dispersion with their, hydrogen bond. I'll be right there, please. Yeah. You would, because it's on the bottom. The metal, not melt. K is the metal, I is not metal. That's why you can't draw the Lewis structure for that one. You got it?
I got, well, honestly, and
Why you got H3 right? Did you?
it's increasing. I mean, just.
Close to the highest.
Oh, I mean.
Try not to say that.
So the lowest to that?
I'm used
Almost.
to writing that.
The first two, what would you like to see H4 as? No. No. Why is that H4 stop or not? So if it's non-polar, it's what? LDF or dipole? It's non-polar. Yes. You just let them look wrong. Right. Yes. Yes. Yes.
It's like about 2 hours.
What you got? Guys, I don't. Can't even tell me about the box. Okay, on it.
LOL, perfect.
Yes.
Okay, can I do like?
Aren't you doing that? Yeah.
You left that in H3. You lost compound.
So yeah, they'll be out in 2 weeks. In 2 weeks.
Yeah, now you got it right. Okay. I was dipolar. So yeah.
Yeah. This season.
All right, let's talk about what you came up with. That way we have time to talk about homework.
Yeah, I'm just saying.
All right. This one's covalent. Covalent. Metallic. Ionic. Covalent. That automatically means that Ni is the highest, Ki is the next highest. So the other three you need to draw. Okay? So NH3 has a lone pair. CH4 has no lone pair. It's just four hydrogens around the C. And then, what was the other one? PCl3. It's crazy lines. I don't know how y'all are supposed to make heads or tails of that. There's 2 dots on top of the P, and then there's 3 single lines. And there's 4 single lines on that C. So this is non-polar, this one's polar, and this one is polar. Now, if it's non-polar, that's London dispersion. These two are dipole-dipole. So a lot of people, when they see dipole-dipole, they go, oh, how am I supposed to tell the difference? But, Madison, hush. If you have dots and a hydrogen, what does this tell you this one is? That's hydrogen bonding. It doesn't matter that this is dipole-dipole. Hydrogen bonding knocks dipole-dipole out. So that means it's stronger than this one. So this one is the strongest. Okay? So, if I go back, The strongest is NH3 because it had hydrogen bonding. The next strongest was the polar one, which is PCl3. And then the weakest was the LDF, which is CH4.
I had it, I thought it was.
Now, if you wrote it backwards,
Yeah.
you got the order right. It's just backwards. We said go from increasing, which would be lowest to highest this time. Okay? Now, for homework, I'm giving you review on the periodic table tonight.
Thank you.
Okay? Instead of bonding, I'm keeping the bonding homework, or the bonding review for tomorrow in class. We'll make Cecilia help me hand it out. Tomorrow, your behavior determines how much time you get for review. I'll be honest, I have not been impressed the last few days.
Yeah.
Based on what I've seen, your review will most likely get cut off
Why?
because your behavior's been less than stellar. So, if you come in with the same attitude and want to socialize and not work, tomorrow I will hand you the 2 review sheets after we go over the homework. And if you spend your time socializing after about 10, 15 minutes, we will move on to the gas law. Because I don't need to review. No need to review. The test is done, ready to go. We have stuff to do. We can move on. Okay? If you work, I have no issues with reviewing. I'd like to have very few test corrections. 1, I don't want to regrade the test. And 2, I don't spend my afternoons with you people. Okay?
Girl, yes, you do. Stop lying.
Are you staying after school tomorrow?
No, I'm only staying today. Okay? So, if you